Good morning. Hi, I'm Dario from AID's department, Savidan Engineering College. Today, I'm going to present about the project. My project is on multimodal framework for yearly reduction of dementia. Yes, let's move on to the agenda. In my PPT, we are going to see about the introduction, statement of the problem, scope of the project, methodology, outputs, results, test cases, conclusion, and future work references. Okay, let's move on to the introduction. Dementia is a progressive neurodegenerative disorder that affects memory, thinking, and daily activities. Early detection is critical to slow disease progression and improve patient care. This project proposes a multimodal AI framework that combines brain MRI analysis with clinical and speech data. Our statement of the problem is challenges. Early symptoms of dementia are subtle and often overlooked. Traditional diagnosis depending on isolated clinical tests and objectives are enable early detection of dementia using AI, combine MRI, clinical and speech data for improved accuracy, provide explainable prediction for clinical understanding. Next, we are going to see about the wait a minute. Okay, let's see about the scope of the project. Scope of the project is the scope is develop a web-based AI system for early detection of dementia, integrating brain MRI, clinical and speech data, provide explainable AI outputs to support clinicians. Next, we are going to see about the target audience. So, neurologists and healthcare professionals, hospitals and diagnostic centers, elderly individuals and caregivers. And deliverables are trained multimodal AI model for dementia detection, Flask-based web application with SQLite 3, explainability visualization using GradCam. Okay, let's see about the second scope of the project, inclusion. That is, brain MR images for feature extraction, clinical data related to cognitive health, and exclusion or real-time or continuous monitoring systems, automated medical diagnosis for or treatment decisions. Okay, next we are going to see about the data, that is publicly available and benchmark MR data set we have taken, structured clinical attributes related to dementia, speech features extracted from cognitive assessments, data stored securely using SQLite 3 database. Limitations are model performance depends on quality of MRI and clinical data. Not suitable for real-time dementia monitoring. Generalization may vary across different populations. Okay, let's see the methodologies we have used. First, data collection, collect brain data images, clinical data, and speech samples from dataset. Data pre-processing, MRI images are resized and normalized. Then feature extraction, MRI features extracted using Inception V3, speech and clinical features combined with image features. Classification, multimodal features classification classified using XGBoost, explainability and web deployment. GradCam used for explainable prediction. Flask-based web app enables remote monitoring and cognitive assessment. Then the architecture diagram is, first we are moving from user to dementia web page, and then we have to log in our page. Then it shows the dashboard. In dashboard we have memory test game, voice based cognitive score, and input data. So in memory test game we have three test games. One is speech and only speech upon then sequence task and voice based cognitive score. So from these three test games we are generating a average MMSE test score. Then we have to import the input data in the website itself. Then about the dementia data set. So first we have collected the dementia data set, then data pre-processing, feature extraction, inception v3 algorithm with XGBoost, then model build. So then we have imported the explainable AI. Then through the model and also the scores and the input data, we have detect the dementia level and we have visualized it through GradCam visualization, which is an explainable AI. So design use case diagram. So UML diagram, use case diagram. Yeah, use case diagram is a graph of actors, set of users cases enclosed by system boundary communication association between the actors users. So this is our use case diagram. So user to server. So in the center part we have dimension data set, pre-processing, inception v3, model build, explainable a memory test, voice based cognitive input data and detection of dementia. Then let's see about the class diagram. In class diagram we have these much boxes, that is user, MRI image, clinical data, speech data, dementia detection model, clinical data, AI based dementia detection system, then database manager. Then let's see the sequence diagram, which is an e-commerce sample. So here we have web application, data pre-processing, AI model, and SQLite. Then the algorithm used, Inception V3 used for feature extraction from brain image, pre-trained deep learning model that capture spatial and structural brain patterns. XGBoost. It's an extreme gradient boosting used for classification of dementia stages. Combines feature from MRI clinical data and speech data. Provide high accuracy and fast performance. So let's see about the important code segments. So here, before that, we are going to